and now it's walking through, and it started with all, it moved on to Redis server, started building the objects needed for Redis. And welcome back to episode 11 of Haskell from Scratch. In the last episode, we didn't change or add all that much code to our implementation, but we did give it a go at replacing make in Redis, and in doing so, we fixed a couple problems in the implementation. In this episode, I want to continue until we can completely replace the makefile for Redis. So to begin with, let's take a look at the redis CLI.do from the last episode, and let's make a change here because really this depends on this redis CLI binary depends on these two objects. One happens to be a library, but effectively, if we make this change, our redo of change line is a little bit more accurate. So let's save this and go back and redo the redis CLI. And I want you to take a look at this line here that says redo if change, and it has ... deps hi redis, open file does not exist. So redo if change was working through this list of objects, and it got to one with this file name that has some directory components in it. And when it went to try and store the MD5, it failed because the directory doesn't exist there. So we need to solve this problem because redo if change should be able to point to any file on the system, not just ones in the current directory. There's a few ways to do this. The first one I thought of was, well, why don't we just escape the directory characters in this? But this isn't a good idea. Even if it does work, it's just going to lead to confusion. The second idea, instead of having these individual MD5 files in the redis CLI directory, we can have a single file that's something like a tab-separated values file with file names in column 1 and MD5s in column 2. That would work, but it would probably involve changing a lot of code, especially because if we want to remove or add individual lines, we need to open the CSV file, make a change, and write it out. Whereas right now we're just dealing with single files. The third idea, which is pretty simple, may have some drawbacks, but I like sticking with simple for now, is instead of having the dependency file name as the file name and the MD5 inside of the file, we can reverse that and have the MD5 as the file name and the path inside the file. And that would get around this problem that we have. So why don't we go ahead and make that change? So we'll go into the source for redo. The first thing that we should do is we're writing out MD5s in two places. We're writing here and we're writing up here. Why don't we just consolidate this into a single function? We'll just use this existing one from the where clause as the template. So we have a target, which is a string, a dependency, which is really a file path, and we're not going to return anything in the IO monad. And so we need the MD5, and I'd like to use the name MD5. It's simple and descriptive, but it's going to clash with an import unless we import this qualified as MD5 and change this here to MD5.MD5. So now we can use MD5 as a label or variable name or whatever you want to call it. So we'll say that MD5 is MD5 prime of dep. And while we're at it, let's change the name for MD5 prime as well. That's not a very descriptive name. Let's say we'll call it file MD5. Just replace all these occurrences, even the ones we're about to delete. So this will be, instead of writing out the MD5, we're going to switch things around here. We're going to write out to the file name MD5, and we're going to write out the dep to the file. So now let's replace, we don't need this where here because we have the right MD5, and we want to change this to use write MD5. So we need to give it the redo target and the dep. So target, and the dep in this case is the path to the do script. So let's see where that's gotten us. It doesn't appear that we have any errors, so let's try compiling this. Go back to redo, redo install. So now let's clear out this .redo directory and try rebuilding Redis CLI one more time. So I don't see any errors this time. Let's take a look in the .redo directory at what we end up with. So Redis CLI now is a list of MD5 names, and if we look inside them, we can see the actual path. So that was a relatively simple change, and I don't think it really calls for much more testing. It seems pretty easy to reason about. So the next step is looking back at this makefile we have here. And I mentioned that the makefile for Redis is pretty simple, but there is one complex thing about it. And I want to explain this because it shows off one of the nice features of redo, and one that's actually mentioned in DJB's documentation on his site. So there's this persist settings target, which looks a little bit strange, and there's this .make settings. We saw it briefly in the last episode, and if you search for persist settings, you get these cases here where when previous final C flags is different from final C flags, persist the settings. So I read through the code and pondered it for a little bit, and it seems that what's happening is that the makefile has been written in a way that it notices changes to C flags in between invocations. And this becomes important for targets like 32-bit here, or maybe there's other targets like gcov. I guess it's a coverage target. So there's quite a bit of complexity in this makefile to handle this situation. But the redo way of doing things, or the DJB way, is to, instead of depending on environment variables like this, to have, say, a script that has all the flags and so on in it. So you'd end up with a redo if change CC. We'll take this CC out here, and in this case we're linking. So you'd have a linking script with all the LD flags in it. You'd depend on that script, so if the script changed, you'd run this again. And then instead of Redis LD, you would run this linking script here. I know this might not be completely clear right now, but what I'm going to do is go through the makefile, convert it into do scripts, and then show you what I've done so that you can see how we're going to do things a little bit differently with redo. And I just realized while making some changes that while writing these files out to these MD5 files, I forgot to read them back in correctly. So instead of deps, we're getting MD5s. This should be a simple change, but I want to show you on camera. So we'll dep up to date, we'll give a string. It'll be the old MD5. The dep will be read out of the file, the old MD5 file. And then the rest should be the same. Okay, and we're back. So this is the new Redis CLI.do file. It's actually a little bit simpler because some of the complexity has been factored out into building this LD script. So now we still have a list of objects, and we say that we're going to rebuild this target if the LD script has changed, or if any of the objects have changed. Now the LD script, when it's built, looks something like this. And it wasn't written by hand. Itself, it is built by a do file, which echoes out the script here and sets it to executable. So there's this redo if change environment. And this is where most of the code from the makefile went to. And all I did was go through the makefile and take bits and pieces of it, converting them into shell syntax from make syntax. So release header wasn't actually used. Uname s here was I simplified it a little bit. The This conditional assignment here is how it looks inside of a Bourne shell, and so on. And it spans about 70 lines. So this is a bit of a stopgap measure to working with environment variables. So the Makefile is designed to look for certain environment variables and change how things work, especially based on the type of malloc needed and a little bit of changes based on the platform we're building on. So this ld.do, if it notices that that environment file has changed, it's going to source it and then use the resulting variables to generate this script. So this isn't a perfect, faithful transcription of the Makefile, since the Makefile is designed to notice changes in the environment every time, whereas once we have this LD built, unless the actual environment file has changed, we won't get any changes. But it does have the advantage that instead of having to look at these variables every time, once that LD script is built, we can quickly do all the linking that we need. Now, another change that I had to make was for building these object files, which is a much simpler rule here as well, in along the lines of the change we made to Redis CLI, and that is that we look for a CC file, which looks something like this, and it itself is built in a similar way to the LD script. This line here, redo if change, this is basically, you can see it in the Makefile. Let's see where it is. Right here. The Makefile includes makefile.dep, which is this list of dependency rules that's generated automatically by GCC. So this is an easy way of, instead of manually specifying the dependencies for these object files, you can generate them with GCC. And I've basically done the same here per C file. It's calling the CC script. It needs to be this script to have the include paths correct. Then it's just taking out the head of the rule here. It's removing any of this extra new line stuff because this format is designed for make, but we're using it for redo. So it's just a nice way of automatically determining when a C file or when an object file is out of date. And I made a few other do files. Let's take a look here. We'll come back to some of those. There is inst, which is basically the same thing as CC and LD. You can see it's similar here. It's called that because install needed to be a do file to do the actual installation. If we're going to copy the way make does things, where you do make install, we want it to be redo install. So this is basically the same as this rule right here. And again, if I'm going through these too quickly, you'll have a chance to look through the repository on GitHub where I'm going to push all these changes. And here's some interesting ones. So basically, just like we did with Redis CLI, each of the binaries I have created a .do file for. And there's some duplication. They all do the same thing. Set up an object variable, redo if change, and then LD. And I might get rid of some of this duplication in the future, but for now I just want to keep things simple and understandable. I also copied over some of the rules like clean, and whoops, this needs to source the environment because the environment has the binaries declared, so that we could say redo clean. All of this up here that you see above is the environment script being sourced, and since we're using -x, we get everything printed out verbosely. So now that all these do scripts are here, let's actually see everything in action. So there's one other do script, all.do, which just goes through and redoes all the binaries. Actually, I can binaries, and we'll source the environment. Okay, so let's do redo all and watch it work through everything here. So for me, this is really exciting to see in action because it just went through and built everything without using make, essentially the same way that the real make build system does it. But seeing all these shell lines and all these true and false and everything else printed out is a little bit distracting. So I think it's time to go ahead and get rid of them. And we might add this -x back in as a command line switch or something like that in the future. But for now, let's get rid of it. Let's get rid of the trace show. Let's get rid of this other trace show. And let's print out the line redo and the target. And we'll only print that out if we actually go ahead and rebuild it. If it's up to date, there's no point printing it. Or at least we want to be able to show the user each of these lines is work we're doing, and any work we're skipping we won't print anything for. So just for fun, let's reinstall this and then take a look. Again, we're going to clean and then all. But notice that clean didn't print anything, and if we look at, say, redis CLI, it's still there. So I'll give you a second to think about why that's happening while I open up the source directory and take a look here. We have an empty file named clean. Clean here, the clean rule, doesn't depend on anything. It just takes some action, and it really doesn't build a target either. And what happens is that it creates this zero-length file, and since it has no dependencies, when redo runs, it says, well, I already have clean as a target and it doesn't depend on anything, so I'm done. This is, in the Makefile, what's known as a phony target. If you look, it's specifically marked with .phony, and this is a way of telling make that, hey, this doesn't actually build anything. Now, traditionally, this clean rule is placed in here because it has access to all these variables and so on. But in our case, since our do files are already shell scripts, and we can source this environment to get the list of binaries, this would really be better off as just a script, not a redo script at all. Instead of saying redo clean, we'd just run clean. But people are used to this sort of way of doing things, and this gives us an excuse to fix this, because this is a real problem. If we have a rule that doesn't generate, or we have a do script that doesn't actually generate a target, we want to handle that gracefully. So let's go back to the source. And I think the simplest way to do this, instead of introducing any new syntax or new commands inside of the file, like redo phony or something like that, let's just check to see if any output was produced. And if no output was produced, the temp file should be 0 bytes long, and we'll just remove the temp file and not move it into place. So right here, we'll say that the size is file size of the temp file, and I need to write file size because that doesn't exist by default. So it'll take a file path and give us an integer in the IO monad. So file size, for the path is, we're going to use with file again. Let's just copy an instance we already have here. With file on the path in read mode with, instead of hgetLine, we'll use hFileSize, and we'll import that size. Okay, so here, actually we'll want to do this here. If the script ran successfully, we'll say if the size is greater than 0, then we'll rename the file, and if not, then we will remove the file. So reinstall this. I'm going to remove clean, and now let's try redo clean, and make sure that it hasn't left a file there or any temporary file. And now if we run it again, it's going to run again. Okay, so let's do everything again. And this is strange. So redo all should be noticing. Oh yeah, that's right. This is probably suffering from the same problem we just fixed. So let's try this again. Let's clean and run redo all. And now it's walking through, and it started with all. It moved on to Redis server, started building the objects needed for Redis server, and we'll see it link and build the rest of the binaries. And there you have it. So it might push the episode a little bit long, but I'd like to make one more change to our redo implementation, and that is to support something like what's being done here, which is recursive make. We want to be able to handle recursive redo. We want to be able to have a file like this all.do in the top level directory that says redo source all. So in order to do this, if we try to run this right now, the problem is that the current working directory is wrong, and it's looking for environment in the current directory. It's not in the current directory. So what we're going to need to do is here we want to basically break any target into directory and file name components. Then set the current working directory to the directory component, and then continue as normal. And we need to do this for every target we've got on the command line. So I think the simplest way to do this is to rewrite this a little bit. We're going to send the arguments into a map of a function that gets an arg and has a little do block here. And so first we're going to need the current working directory, get current directory, and there's set current directory as well. And so let's say the top level directory here is the get current directory. And when we're done with this, we want to set the current directory back so that when we write out the MD5 files, we're in the right place. So we'll set the current directory to top dir. And so here for each argument, we want the directory and the path to be, there's a file path function called split file name. And if we pass it a path, whether or not it has a directory, it will do the right thing. Split file name of the arg. And so then we can set the current directory to this dir, and then run redo. Wait, this mode is a little bit confused by indentation here. Run redo on the path, or let's say the file part of it. And you know, we can actually set the current directory to top dir right here. So notice there's a fly make warning here because trace show isn't used anymore. I'm just going to leave that for now. So now, if I've thought about this correctly, once we've redone the installation, we should be able to do redo all here. And we've run into a problem. It's running twice. Oh, I didn't remove this old line here. Let's try this again. So let's see what we get. So this output's a little bit confusing because it has stripped off the directory component. Let's keep that in. Let's print it. Oh, how are we going to do this? Well, this is a little bit hackish, but I'm going to pass the top dir in here. And the hackish part is really this redo function shouldn't be using this, but we're going to add it in just for the Let's show and join these here. So it's a bit of a hack, but I don't want this episode to go on too much longer. Well, and top dir is not even the right one here. Sorry, dir enter. And thanks to hlint, we can make this a little simpler. And now one more time. Okay, so it's not perfect yet, but that's what you get when you throw a hack into some code at the last moment. So that's it, really. I'm just going to run this one more time with our new changes here. Redo clean, pop D, and then redo all. So there is a couple things that are missing from the redo version that are in the Makefile version. One of them is that in the Makefile, there is in the other Makefile here, there is these targets here that invoke make with some different flags. And this is something that I mentioned earlier that we can't really do because we have no way in redo to check environment variables to see if they've changed. Now, that might be an interesting feature to add, but I want to stick to strict redo until we have a compatible or mostly compatible implementation, which I think we're pretty close to. There's one thing that we haven't done, and that is redo if create. And it could be used in a way like this. In a 32-bit rule, we could echo out some flags into extra flags and then redo everything. And then inside of our cc.do, we could say redo if create extra flags. And then we could say here, if the file exists, then I forget offhand what the test for that is, but if extra flags exist, then we can include them into the C flags and so on. But before adding a feature just because it's in the original implementation, I want to understand its motivation a little bit better, so I'm going to hold off on that until another episode. But here we are finally with, as far as I can tell, a pretty robust implementation of redo in, let's see here, less than 100 lines of Haskell. So in the coming episodes, I want to take a look at, we're not done just because we've gotten this working one time. We still need to, for example, profile the code, see how fast it is, see what the memory usage is like, as well as document it. I know it's still under 100 lines, but it's getting a little bit difficult to understand if you haven't followed along through all the episodes. And even then it might be a little bit confusing at times. And as we document the code, we'll probably get some ideas for refactoring along the way. So I'm really looking forward to the upcoming episodes, and I hope you are as well. Thanks for watching, and I'll see you next time.